Buenas tardes. This afternoon I'll talk about the Internet of Things. I can tell you that the Internet of Things is still under development. I know some statistics. How many people have heard of Internet of Things? About 20%, should we say? 25%? The average is about 13%. Only 13% of people in studies are familiar with Internet of Things. How many people have a cell phone, a smartphone in the pocket? How many people know how many sensors are in this smartphone? Over 20. You are already connected to the Internet of Things. You just don't know it. If we look a little bit at the past, next please. On the left-hand side, you have one of the first Internet of Things machines. Was a Coca-Cola machine connected to a PDP-11, a very old computer in Carnegie Mellon in Pittsburgh. And it had only a very simple function. The machine had 6 buttons, but you don't know which of the buttons will give you a cold Coca-Cola. So what they did, they put some devices in the back of the machine, connected to the computer, and now they were on a different floor, the students. They didn't know to go down and check if the machine has Coca-Cola or not. And this is one of the first Internet of Things. But then, around 1991, a very interesting idea came about, and that was from Mark Weiser. He's the inventor of the term ubiquitous computing. And in what he said is that the most profound technologies are those that disappear. So how many people think that their smartphone is a computer? How many people think that that computer is much more powerful than probably Cray computer was the top of the line in the 60s? And it is. Today, as I mentioned already, a smartphone has over 20 devices. It can measure pressure, temperature, it can measure altitude. And if you carry an apple, for instance, it has a sensor for water, so it knows if your smartphone had been dropped in the water, it voids the warranty and sends a message back to Apple that don't check it because the person dropped the computer. So this is the IoT today. Moving on, we're moving toward, as I'll show today during the presentation, we're moving to a new universe where everything gets connected. Smart cars, smart cities, smart water. I'll talk a little bit about mining, because Chile is so much dependent on mining industry, healthcare, education, and so on. Let's look at 2 aspects of that, social and economics. As I mentioned before, 87% of people surveyed in 2014 were not aware about Internet of Things. But you know what? They were using it. This is the ubiquity of the computing platform. We use it without knowing. About 64% also, they were not aware about smart appliances and smart devices connected to, and about 40% did not know the wearable, things that replace your smart watch. You may have a watch which measures your pulse, your heart rate, and so on. And if we move on, how we got here? How we got to IoT? How we got to Internet of Things? We got here by building on a virtuous cycle. You already started to show that. First thing, we had the humans. And together with the humans, we brought the sensors, the smartphones, the wearables. The next level that I'm sure you know, I'm sure all of you with a smartphone in the pocket knows that you can connect it to the mobile network and the Wi-Fi. That's what we call hyperconnectivity. Every little sensor in the smartphone, every little sensor around us can report through the internet back and collect the data in the cloud or in the big data structure. But that's not enough, because this massive amount of data, it's amorphous, it's unstructured. And unstructured data means nothing, it's gibberish. Try to read a book by reading every 7 words and try to understand what it's about. That's about that. So really, the next level, it's the analytics, is applying to the big data, to this massive amount of data logic, and transferring the human logic into the computer, into the machine, so we can create models of real life, of physical life, predicting, for instance, heart attack, predicting traffic jams, predicting water shortages, and so on. This virtuous cycle touches now on all the main industries, from manufacturing and the Internet of Things. We talk about the industrial Internet of Things, manufacturing, healthcare, utilities, finances, communications. But it also touches on the consumer, the Internet of Things of consumers, retail, shopping, personal health, sports, and so on. How are we going to look at the Internet of Things? Let's look at the picture as I started. In about Internet of the future, 9-10 years, we're going to see a split of the Internet of Things by different industries. About 22% will be on smart devices. Other percentage go to smart manufacturing, robotics. Robots, of course, have a lot of sensors, have vision, have movement sensors. Studying Huawei, we're starting to look what fuels this virtual cycle, this ICT cycle. And we came up with a model, we call it the Global Connectivity Index, that connects the Internet of Things, connects these sensors with the telecommunication industry. We call it the ICT, the integration of the IT technologies with communication technologies to create a single platform to support the Internet of Things. If we look, for instance, at the index, we can find out where Chile is today with the Internet of Things. We can find out that Chile, it is in the middle range in terms of connectivity to the Internet. There is still work to be done, like any country in the world, really. Even the ones on the top, which are the Nordic European countries, or the one a little bit more down, like US and Canada and so on. If we look at the connectivity also, there are good news. And the good news is that in the group of 3 developing economies, Chile is actually on top. It's better than China, and it's better than Brazil. And this is really important because without the fundamentals of connectivity, you do not have Internet of Things. You cannot exchange all this information, build this big data, build the analytics on top of it. If we look at the big picture again, analysts are considering the Internet of Things of going in about $10 to $15 trillion to be added to the global GDP, global development in the world. And in the interest of time, I'll not go in different parts of this industry or the parts of this analysis, but we can pick up an example. For instance, the number of devices connected today, the IoT devices connected to the Internet, it's under 1%. How much more work we have to do? So we are really just at the beginning of understanding and using the sensors and the devices connected to the Internet in order to create the world of Internet of Things. Let's look again at Chile. In Latin America, the Internet is growing very fast. If you look at the data, it's growing fast, but when you look at really at data and you look 23% growth in Latin America, it comes from a very low basis. So there is a lot of room to grow. Most Latin American countries are under 30% in terms of broadband penetration, Internet penetration. Chile has a special status. Chile is about 66%. So, as I said before, this is a fundamental element in measuring where the global connectivity index is and how much work has to be done before we start to build a real economy based around Internet of Things. So good news, and as I'll explain later, there is still work to be done, and we can do a plan together. So let's look at some services of Internet of Things, and I brought some examples because I think we can talk about services the whole day. The first thing on the Internet of Things, we need to talk about cloud. Cloud computing, it's taking the computing platforms to a next level. It allows the creation of massive data centers, if you want, interconnected with very massive, very powerful computing hardware, with software which allows to interconnect and exchange and distribute the load of the computing, and then we have applications and services running on the top. This is the basic of a cloud. You've probably heard of Amazon. You've probably heard of Google. It's a building block. Then if we look at technologies that we have one problem. Bandwidth is not enough. Bandwidth is not enough because when you have 1 billion sensors connected, cars, temperature sensors, pressure sensors, healthcare-related sensors, blood pressure and so on, if you have them connected, trying to connect them to the internet, there is not enough bandwidth, there is not enough spectrum. We're looking at, on the right-hand side there, we're looking at technologies or methods to better use the available spectrum to connect sensor to the internet. We call it narrow-band Internet of Things, or narrow-band IoT. And finally, when you think about one other example I picked up is emergencies. Unfortunately, Chile, like many countries on the west coast of Latin America, are prone to earthquakes, are prone to emergencies. And we have technologies, we call it LTE trunk radios, that go on top and allows you to connect the emergency Internet of Things, if you want, the sensors and so on. And let me talk about some examples. What you have here, it's a bicycle, a simple bicycle, that transmits a little bit of data through this narrowband technology that I described, transmits location, transmits data about the mechanics of the bike, if anything it's braking, and maybe the speed of the bike. This very little amount of data has to be constantly transmitted in order to create this massive amount of data that we call it a cloud or a big data structure. And this is just a simple example. And when you're looking at the technology, because Huawei is a technology company, we're supplying this kind of technologies to allow to connect the sensors, to allow to connect the vision and so on to the internet. We can see how we can reuse the existing mobile network to just upgrade it or update it, if you want, in order to support narrowband technologies, in order to support all these millions and millions of sensors. And here it's a little bit more larger picture. When you start to look at different sensors, we have sensors we wear, I mentioned before, wearables. We have meters, smart meters that allow you to turn off or determine if the water quality is not good. You have smart sensors in the highways or in the roads, measuring the traffic, measuring the pollution, and allowing you to find parking spots easily. So you can see that in the next 10 years, we have plans for, again, billions and billions of connections and billions of sensors. This is just a simple example of big storage, big data storage. We had before astronomers talk about big numbers. These numbers are bigger. I didn't compute really, but I would think that maybe we have already so much data that exceeds the number of the stars in the galaxies. I won't read the slide, but you look at astronomers, for instance, on the left-hand side, in 1 hour, they generate petabits of astronomical data. This is how they can get these nice pictures on the screens, by processing huge amounts of data, filtering and creating the image of the stars. This is just about storage. Okay, what do you do with so much data? We collected it, and as I said, it's unstructured, as you said as well. It's unstructured. Now we have to start to look into the data, dig deeper, use a lot of computing power again. That takes electricity, by the way, and heat, and creates heat, in order to extract data that serves different social, economic, and personal functions. For instance, marketing. For instance, sales, for instance, measuring operations, helping with operations from airlines to trains, I'll show in the next examples. This virtual cycle ends with the analytics for the big data. Starts with the sensors, building up all this information, and now we have to process it and eventually use it, make it something which is usable. And in big data, there is a simple paradigm. In a big data, only the questions are important. Once you know what question you want to solve, then there is computing power. But until you don't know the question, you cannot find the answer. It's sort of the other way around. You can guess the answer, then you find the question, then you eventually check the answer is correct. Smart cities, just a blueprint. If you read about smart cities, 65%, two-thirds of the GDP, of the total economic output, It's done in 600 cities. Traffic jams. Traffic jams in the US consume about 2% of the available time of the people. And this is not the worst example. The worst example is in China, a traffic jam took 11 days. So we're talking about massive economic losses. We're talking about loss of opportunity. We're talking about pollution. We're talking about everything which is wrong with the traffic jam. So transportation has really the largest saving potential in the smart city part. People spend a lot of time waiting for their connection on their transport. How many people have the experience that they came to see the bus or the subway leaving exactly the moment they were coming into the station? Statistically, it seems to be 50%. But on the right-hand side, what you have there, it's something else. It's a new economy which is starting to be born under the Internet of Things. This is the shared economy. This is the shared rooms. This is the Uber. Without sensors, without the sensors in your phone and the sensors in the phone of the driver of an Uber car, you'll never know how to connect. You'll not be able to find each other. You won't be able to call the Uber. The other thing is the smart home, and here it's an example. We're looking at 4 elements in the smart home. We're looking at the cloud, which I explained before. We're looking at the analytics, the ability for the computing system, for the IoT system to understand temperature, to understand if the person is at home, to understand if it's an alarm safety problem because the cat just broke a vase, or it's an intruder in the home. Energy management, the electrical power heating, as well as water. And finally, home health. Another example that I brought today is it's a test for smart parking. It had been done with China Unicom. Under each car, as you can see there is a sensor introduced under the car. It talks to the sensors in the road, and it can help the driver to find where is the next and the closest parking spot, so you don't spend all this time and trying to get a parking. This had been implemented again with the technology I talked before, the narrowband wireless. So if we think about the mining activities, there are a lot of elements that can be integrated through the Internet of Things, from maintenance, management, health and safety, providing the people with sensors, knowing where the people are. I talked about wearables. A simple GPS on each miner can tell all the time where the person is, if it's moving or it's not, what's happening. That creates actually another interesting part, which I really didn't talk much, and I don't have too much time to talk about, but the opportunity to develop locally R&D, research and development, around this kind of technologies. This is not only the kind of technologies that have to be developed by large corporations like Huawei or like IBM, but also can be done through startups. This is where the sensors are cheap and available. The knowledge is important. The other technologies exist. They can be put together. But the knowledge and the capability to extract this knowledge, to translate it in something that is useful, is local. It depends on the people that work in that industry. Smart water. Look at Chile, look at Peru. Water stress by the country, that the resources are already stressed. One of the astronomers this morning showed a very interesting picture and said, the Earth is a dry planet. We think of the Earth being full of oceans, but he said the mass of these oceans, it's small. We're already in danger of exceeding water supply. Look at all this bright red in the maps. Measuring water, measuring the quality of water is very important. People get poisoned by lead, for instance, in many countries. That creates a generation of people with disabilities. And this is an example. This is a commercial example launched actually late last year. And the reason I picked up this example, beside the fact that Huawei was one of the providers, was that we look how many companies and how many parts form this ecosystem. We had the Vodafone. Vodafone is a European and African operator for telecom. We had to work with another part of the industry to create the module which gets into the water meter, which connects to the network, which has the intelligence to understand the system and understand water leakage and water quality and so on. And eventually, a water company launched this service so they can send accurate bills, they can determine leakage, they can inform the consumer if the water bill is too high, and so on. Very quickly, let's go to some conclusions and more importantly, some recommendations. We talked about, really quickly, impact on society, impact on individuals, on people, economic impact, the welfare of people, how Internet of Things can change our lives, can make our lives better. And of course, we have no time, but we have to make sure that it's better, and also there are no impacts on public safety or on privacy of the individual. But when we'll have hundreds of billions of things connected, industry, transportation, agriculture, services will change. They change already. Yesterday I was talking to a colleague, and he told me a very simple story. His father has walnut groves. They grow walnut trees. And they just put a system to measure the humidity of the base of each tree and increase the production. Similar to your examples. So there are many, many examples on the world where IoT works. Again, I started by saying only 13% of people know about IoT, but I think about 80% are using it already. So a couple of suggestions and recommendations. First, please. Global Connectivity Index showed clearly that economic growth is interdependent with IoT, and it's interdependent with the information and communication technologies. This integration between communications, internet, and computing platforms. Chile can become really a global center of excellence. Speakers before lunch talked about development in Chile. They talked about the creation of the Ministry of Science and Technology. Here it's maybe project number 1 or 2, if it's not already a backlog of projects, but here it's something that can be developed locally because the knowledge is here. The technology can be put together, but the knowledge is here, and the knowledge is the most important fact, is this analytics, this ability to extract information and value out of the data. And of course, politically and regulatory and telecom industry has to work together to create better infrastructures, keep investing in the infrastructure, investing in additional technologies like narrowband of IoT in order to create the right framework for the country. Thank you very much.